Okay, lesson 3.2 is about proving lines are parallel, and our objectives are to use a transversal in proving lines are parallel and to relate parallel and perpendicular lines. So, first up, vocabulary and key concepts. We've got a postulate here. Postulate 3.2 is the converse of the corresponding angles postulate. So, it's like switching the hypothesis and the conclusion because it's the converse. So if two lines in a transversal form congruent corresponding angles, then the two lines are parallel. So before we said, hey, if we know those two lines are parallel, then the transversal forms congruent corresponding angles. Now we're saying, hey, if we know those two angles are congruent, then we know that the lines are parallel. So in this case, on the side over here, line L would be parallel to line M. Okay, theorem 3.3, converse of the alternate interior angles theorem. So kind of like the converse of the corresponding angles. Alternate interior angles said if we know two lines are parallel, then we know that the alternate interior angles are congruent. Instead, we're saying if the two lines in the transversal form congruent alternate interior angles, then the two lines are parallel. So it's kind of like working in reverse of what we were doing before. So here in this example, 1 and 2 are congruent, so lines L and M are parallel. Alright, theorem 3.4, converse of same side interior angles. So before we said if we know the two lines are parallel, then we know the same side interior are supplementary. So now we're saying if two lines in a transversal form supplementary, remember supplementary means we add up to 180, or the two angles add up to 180. Supplementary same side interior angles then the two lines are parallel. So if we go back up to our picture here, 2 and 4 are supplementary, so lines L and M are parallel. And theorem 3.5 says if two lines are parallel to the same line, then they are parallel to each other. So like right here, if I know that line A is parallel to line C, and I know that line B is parallel to line C, then I know that A is also parallel to B. Okay, theorem 3.6, the last new theorem, says in a plane, if two lines are perpendicular to the same line, then they are actually parallel to each other. So if we look at our picture, line M is perpendicular to line T, line N is also perpendicular to line T, so then they have congruent corresponding angles, which means line M and line N are parallel. Okay, couple vocabulary words here. A flow proof uses arrows to show the logical connection between statements. Kind of like a flow chart uses arrows to show you what to do. A flow proof uses arrows to show you how it connects. All right, and reasons are written below the statements in these flow proofs. Okay, let's jump in with some examples here. Example 1, proving theorem 3.3. If two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. So we're trying to prove that the two lines are parallel. All right, and it's using a flow proof. So it says we're given that angles 1 and angle 2 are congruent. It also states that angle 1 and angle 3 are congruent because we know vertical angles are congruent. Vertical angles, remember, are the ones that are across from each other on an X. Okay, so then, using the transitive property, they jump to this statement. Since 1 is congruent to 2 and 1 is also congruent to 3, 3 has to be congruent to 2 because of the transitive property, which means that line L is parallel to line M. Okay, so now we're going to look at the statements down here for the flow proof. By the vertical angles theorem, angle 3 and angle 1 are congruent. 1 and 2 are congruent, so angle 2 is congruent to angle 3. Angle 3 is congruent to angle 2 by the transitive property. So we're just taking what we said in what the flow proof up here said and writing it into statements. Transitive property of congruence. Everything I've written down, I've just pulled from the flow proof. Because angle 3 and angle 2 are congruent corresponding angles, L is parallel to M by the converse of the corresponding angles postulate. And there we go. So we just proved that these two lines up here are parallel. All right, let's look at example 2, using theorem 3.4. So use the diagram at the right. Which lines, if any, must be parallel if angle 3 and angle 2 are supplementary? Okay, so it is given that angle 3 and angle 2 are supplementary. Start with what we know. Which of these lines, the diagram shows that 4 and angle 2 are supplementary because they're right here. They're going to form this straight line right here. Because supplements of the same angle are congruent, angle 3 and angle 4 are congruent. Because angle 3 and angle 4 are congruent corresponding angles, line EC is parallel to line DK by the converse of the same side interior angles postulate. There we go. Okay, so then there's 2 check for understanding problems you're going to do here. Supply the missing reason for the flow proof from example 1. So up here, what was the missing reason there? And then use the diagram from example 2. Which two lines, if any, must be parallel if angles 3 and 4 are congruent? 3, 4. What lines can you prove are parallel? Okay, so then there's another couple examples to try here. Proof of theorem 3, 6. Use the diagram at the right. Which angle would you use with angle 1 to prove the theorem in a plane if two lines are perpendicular to the same line, then they are parallel to each other? Using the converse of the alternate interior angles theorem instead of the converse of the corresponding angles postulate. So, by the vertical angles theorem, angle 2 is congruent to its vertical angle. So that would be over here. These two are the same. Okay, because angle 1 is congruent to angle 2, angle 1 is congruent to the vertical of angle 2. By the transitive property of congruence. Because alternate interior angles are congruent, you can use the vertical angles of angle 2 and the converse of the alternate interior angles theorem to prove that. So what this is saying is we know angle 2 is congruent to its vertical angle. We know angle 1 is congruent to angle 2, so angle 1 also has to be congruent to this angle. Angle 1 and this angle are alternate interior. Since those are congruent, then the lines are parallel. Alright, and one more example here. Find the value of x for which line L is parallel to line M. These angles are the labeled angles are alternate interior angles. Alright, we've got this one here, this angle here, those are alternate interior. If these two lines are parallel, then their alternate interior angles are congruent. And their measures are equal. So if we write this out, 5x minus 66 equals 14 plus 3x. And then let's copy that down here. Then we're going to add 66 to each side. So now we have 5x equals 80 plus 3x. Then we're going to subtract 3x from each side. So 2x equals 80. And then if we divide by 2 on each side, we know that x has to be 40. Okay, then two more check for understanding problems here. In a plane, if two lines form congruent angles with a third line, must these angles be parallel? Draw the picture. It will help. Find the value of x for which A is parallel to B. So we know that we're looking at these two angles. Those are same side, which means they're supplementary. Big hint there. If you know what supplementary means, you can figure that out. Okay, so go ahead and work on those check for understanding problems. Make sure you're getting them checked with me. And if you have questions, make sure you're